Hi, it's Matthew Reed from How to Repair Pendulum Clocks. Recently, a member of the online clock repair community reached out to us and asked us how you repair or straighten bent clock pivots. If you're involved in clock repair, this is a problem you will come across sooner or later, so let's get to it. So the problem here isn't straightening the pivot per se. It's the fact that what do you do if the pivot breaks off? Or maybe, more importantly, how do you prevent the pivot from breaking off? But it's well worth asking that question before you begin. If the pivot breaks, are you going to be able to drill out the arbor and repivot? Anyway, that's another video. So how do you tell whether the pivot's going to break off or not? Well, broadly, there are two kinds of arbor, like the one that we're using here as a demonstration, which is from a Smith's Enfield mantle clock, where the arbors are soft, so the steel isn't hardened. There's every chance. Not only are these pivots easier to bend, but the beauty is that typically they're easier to bend back as well. If we take this wheel, for instance, from a 19th century French clock, the steel in these arbors is hardened, and therefore it's possibly less likely that the pivots were bent in the first place, but if they do get bent, then there's an opportunity for them to snap off. So what we do is very slightly temper the steel, and we do that by heating gently with a spirit lamp. Now that in itself is not difficult. The challenge is that often the pivot is either near a pinion in this case, or maybe even worse, next to a wheel. The wheel collet on a French clock is soft soldered, so if you begin to heat the arbor with your spirit lamp to temper the pivot, if the soft solder in the collet also melts, then the wheel will no longer be concentric and you've got a bigger problem. So if there's a pinion or a wheel or a collet or something you don't want to raise in temperature, you have to make a heat sink to prevent heat from spreading up the arbor. And you can do that, for instance, here I've used a brass split stake to hold the pinion to absorb heat. You can use a piece of wet cotton cloth, in this case wrapped around the arbor. You could use a pair of brass lined pliers, or there are proprietary cool gels that are specifically made for this purpose and used extensively in jewellery where you want to solder, but you maybe have a ring, for instance, that's got stones in that you don't want to heat up. Now when we temper the pivot, we only want to temper it to bend it back. We don't want to anneal it and make it completely soft. And so that's where we use the spirit lamp, because the heat from a spirit lamp is relatively gentle. If you would begin to heat the pivot, the end of the pivot will become soft, but not necessarily the bit that we're interested in is where the pivot joins the arbor, because that's where they break off. So what I'm going to do here is to fit a bush, just a little piece of brass tube, onto the pivot. When I heat with the spirit lamp, that will itself act as a bit of a heat sink, and it'll mean that the arbor has got a chance to heat up a little bit in relation to the pivot. And what we're looking for here is for the colour of the steel of the arbor to begin to change to what is called pale straw, which is a very kind of pale brown or pale yellow colour, and no more. Because there's less mass of material in the pivot, by the time you've done that, the pivot will have probably got to a temperature that we want, which is blue. These colours are oxide colours, and the only reason we're interested in them is because they indicate the colour that we want. We want the pivot to become blue, but not any hotter. Now straightening the pivot is quite straightforward. Here I'm going to use a piece of bushing wire that's slightly under diameter for the pivot, and I'm going to broach it out until it fits onto the pivot, and then simply by rotating the pivot in my hand I can feel the high point, then very gently manipulate the pivot until it's straight. If you have a watchmaker's lathe or a lathe, that's great. You can put the arbor in the collet maybe, which helps with this process, but it's not necessary. This method with a bushing wire gives you the sensitivity you need for most clocks. Of course, if you don't have bushing wire, you could just drill a hole in a piece of scrap material, brass, and broach it to size, so you have a plate rather than this wire, and that would do a similar job. You could also just use the clock's own plate. Now, I think there's a small chance here of damaging the pivot hole, so that's not my preferred method. But as you can see, using this bushing wire method, you can get the pivot reasonably straight, at least for this grade of clock, and it runs fine when we test it in the frame. Hope that's helpful. So a little recap. The important point here is the gentle tempering of the pivot. That's the difficult part of this process. Once you've done that, then if you are gentle in the manipulation of the pivot, it should straighten, but there is always that risk it's going to break off, in which case you'll need to repivot, and we can maybe deal with that in a later video. So thanks for watching. Don't forget to like and subscribe, and we will see you again.